Okay, kejap Sekejap background saya. Change. Oh, because of this, okay, tapi still. Sekejap. Nampak sangat ni kalau tulis. Oh, tapi dia kayak perzit. Tekan tu. You guys, apa?
Yes, doctor, we can see.
The reflection reflection of the. Can you see the equation 3x1 plus 2x2?
Yes, doctor.
Yes,
doctor.
Equals to 18. Okay, and okay, so this is an example of algebraic equation. And number one, we have means we have two linear. This is a linear equation, so we have two linear equation. If we have minus x1 plus 2x2 equals to 2. Right. Okay, so so the first one, 3x1 plus 2x2 equals to 18. The second one, minus x1 plus 2x2 equals to 2. Okay, so we have example of two linear algebraic equation. So normally we are asked to solve this. Okay, in order to find x1 and x2. Okay, x1, x2. For example, in terms of matrix like this, x1, x2, right? Okay, so first by using the graphical method, okay, graphic means that we try to sketch the linear line of a graph of these two equation. Okay, right. So this is like a linear equation. We have x1, x2. So x2, whether you call it x1 or x2 or you call it xy, it's the same thing. So you have a graph. So this is we call this x2. This is x1. Okay. So how do we sketch these two linear? Okay, so in order, by using the graphical method, in order to solve the linear algebraic equation of these two, so we will sketch both of these linear equation, and what are we going to find? We are going to find the intersection, okay, the cross, the point where these two lines going to intersect, okay, each other, right? So that will be our answer, our assumption, our supposed answer, x1, x2. Okay, so try to do on your own paper, okay, sketch pad or anything, and try to sketch the first line, okay, L1, I call it L1, L2, okay, linear algebra, linear 1, linear 2. 3x1 plus 2x2, 18. So how is the graphic? Okay, the linear algebra. Okay, in the x1, x2 axis, and another one, the second one. Try to sketch it, and then we try to find the intersection point, the connection. Okay, try to do it. So for example, we do just 1, 2, 6 until 8, 10. Here also 0, 2, 4 until 10. Okay. Okay, and then we try to sketch. Okay, this is just a linear straight equation. Okay. So try to guess what is x1 and what is x2. Okay, I give 2-3 minutes. So we are 52 right now. This presentation. Okay. Maybe if you want to see better, you can pin. I think you can pin my video, okay, so that you can see in full screen. I hope so. You can do that. Ya Allah, main lagi. Dah kan? Okay. Okay, for those who just enter, I ask all of you to, we are entering the first chapter, linear algebra. So we try to recall, refresh our knowledge about linear algebra. Okay, so we have these two linear equation, simple linear equation, 3x1 plus 2x2 equals to 18. Another one, the second one, minus x1 plus 2x2 equals to 2. So if we use, like in this slideshow, the first method, graphical method, means that we try to sketch both of these linear equation in x1, x2 axis graph. We try to sketch it and find the intersection, connection of these two linear equation, straight line kan? Straight line equation. So we try to find the intersection. So the intersection will be the answer for x1, x2. Okay. Okay, please mute if I don't call you. Okay, cukup berdengar. Okay. Okay, someone I call. Sejak depan dah. Tak, ni depan ni dah. Okay, Nurul Kristina. Nurul Kristina. Are you there?
Yes.
Yeah. Ada lukis ke? Have you tried to sketch? Did you try to sketch, draw the algebra equation?
Yep.
So did you find the answer? Okay, okay.
This kind of one, sorry.
Okay, okay.
Doctor, I found it.
Okay.
For me, it is Doctor, x1 is 4 and x2 is 3.
Yes, but I'll wait for Christina to show the answer, okay?
Okay, Doctor.
Okay. Christina, dah ke?
Wait, give me some time.
We can write the equation x2 in terms of xy. So we have x2 equals to, for example, x2 equals to minus 3 minus 3x1 plus 18. Okay. So we have the usual linear equation like the 1 equals to mx plus c, right? Okay. Okay, so we have something, another one, something like that, okay? One will decrease, go down, and another one will increase, the function increasing, going up. So we will find the intersection at this point, which will be our x1, x2. So what is x1, x2, Christina? Okay, for the time being, try the second method that I will show you is the determinants and Cramer's rule. Okay, as far as I remember, I think you have learned this method in engineering maths 1. I think with my previous group that I taught the engineering maths 1. Okay, I have taught this about the determinants, how to find the determinants like a matrix. From a matrix, we find the determinants, and by using Cramer's rule, okay, we calculate the determinants and we find the answer to the linear algebraic equation. Okay, try to recall back the method as well, the determinants and Cramer's rule. How to solve linear algebraic equation by using determinants and Cramer's rule. And usually for the second method, we have 3 linear equation, means higher order linear equation, we have more. Because if you have more equations S1, S until Xn to solve, then this graphical method will not will be hard. Okay, it's not easy to just sketch like this. Okay, this is just an example for if you have only 2 linear algebra, then it's easy. Christina, okay ke? Yeah. Yeah, sorry.
I get 4 for x1.
Okay.
Maybe x2.
So S2 you just replace the S1 in the equation, right? Berapa? Apa? Sorry, tak dengar sangat. 3? You answer?
No.
Oh, jawab dah ke tadi? Saya tak dengar, saya kurang jelas. I can't clearly hear you. Or maybe you can write in the chat box. Okay, so the x1 is correct, 4. So if we substitute the x1 in the equation, so we can just simply solve the s2, we get 3. Okay? Okay, that's more okay. Okay, next, okay. So the determinants and Cramer's rule. Okay. Okay, so determinants. Okay. For example, we have a matrix A multiply with matrix X. So X is the solution set of linear set of solution that we are going to find, equals to matrix B. Okay, so means that the linear algebra equation, we can also write the linear algebra equation in terms of in matrix form. Okay, matrix form. So matrix, this one we call matrix A, X the solutions, and equals to B. So normally we will write A equals to A11, A12, A13, A21, okay, A31, and until you have A33, 3 times 3 matrix, okay, 3 columns, 3 row. So we have until A33. So that's how we write the matrix A. Okay, so by using the determinants method, so means that we have to calculate the determinants of A. Okay, so if we have only a square for 2 times 2 means 4 values of A1 just until A22, then the determinants D will just be A11, no, okay. Sorry. If we have 2 times 2 square matrix, then we will just A11 multiply A22 minus A21, A12, just like that, kan? Okay, but if we have the 3 times 3, 9 components of a linear, 9 components of a matrix, so the determinants will be a bit longer to calculate the determinants. Okay, so the rules is the determinant, so A, if you can recall, so we write A11, okay, and in terms of okay, for 2 times 2, okay, so A11, I usually do like this, so just write off this one, this line, and this line. They include the row for A11 in the column for A11. So we write okay, A11 okay, so we have okay, so we are left with these 4 values. So we write A22, A23. I hope you understand, huh? A33, even though my writing is a bit okay. So we the determinants will be A11 multiply with the matrix A22, A23, A32, A33, and then minus the second one A12. So the same, cut out this line and this line, so you put A21, A23, A31, A33, okay, and then plus last one A13, so you okay close the row and the column, so A21, A22, A31, A32, okay. So that is how you solve, how you find the determinants of 3 times 3 matrix, okay. Tak muat lah tu ni. Okay, so in this one A21, A23, A31, A33 plus A13 kan? A13. So this one A21, yeah, okay, yang ni. Okay, so that is the determinants of the equation A, matrix A. Okay, and then okay. By using Cramer's rule, okay, so how do we solve this linear algebra equation? So I expect this is just a theory. So we will see the example of linear equation, 3 linear equations. So we have 0.3 x1 plus 0.52 x2 plus x3 equals to minus 0.01, okay, I read out loud, 0.3 x1 plus 0.52 x2 plus x3 equals to minus 0.01. Okay, the second equation, linear equation, 0.5 x1 plus x2 plus 1.9 x3 equals to 0.67. Okay? 0.5 x1 plus x2 plus 1.9 x3 equals to 0.67. Okay, last one, 0.1 x1 plus 0.3 x2 plus 0.5 x3 equals to minus 0.44. Okay, 0.1 x1 plus 0.3 x2 plus 0.5 x3 equals to minus 0.44. Okay, so we have this three linear algebra equation. Okay, so if we have to rewrite this linear equation in terms of matrix just now, A. So the the term for A, for example, A11 will be 0.3, A12 0.52, A13 is 1. Okay, and then A21 0.5, A22 1 plus A23 1.9, okay, etc. etc. And this will be the matrix B, minus 0.01, 0.67, minus 0.44. Okay, so that's how we convert the linear equation in terms of matrix. So X will be S1, S2, S3 that we have to solve. Okay, so by using okay, by using the determinants, okay, so we calculate the determinants here. Okay, so if we maybe I couldn't write full. I just write the first part. Okay, so like just now A11 we have 0.33. Okay, so and then we will use 1, this one, 1.9, 0.3, 0.5, okay, minus 0.52, okay, 0.5, 1.9, 0.1, 0.5, plus 1, 0.5, okay, 1, 0.1, 0.3. Okay, so so we calculate these determinants. So this will be you solve this one like this, and like S cross here. Okay, 1 times 0.5, 0.5, 0.3 times 1.9. Okay, so kira lah 0.5. Okay, minus 1.9, 0.3. Okay, apa? So this is one part, and then second part, third part. Okay, so try to calculate that, the determinants first. Okay, so if we call it, I call this one A1, this term A2, and the third term A3. So try to calculate A1, A2, A3, and plus minus, so we get D, the full determinants for matrix A. Okay, try to calculate that. A1, A2, A3, and then solve the determinants. Okay, maybe I give I ask one by one to give chance to everybody to answer. Okay. The first one, this one. Okay, so Ishan, what did you get for this one? Just this one, A1.
I just need 1 more minute, doctor. I'm almost
Okay.
there.
I need to use calculator.
Doktor,
Yes.
doktor nak A1 je.
Nak semualah. Tapi saya tanya seorang.
Okay.
Okay, Hasha nak bagi Hasha nak bagi the answer for A1.
Saya dapat determinant tu negative 2.2 times 10 to the power of negative 3.
Macam tu. Determinants yang the whole the whole
The whole. Ni untuk determinant semua. Negative 2.2 times 10 to the power of negative 3.
Oh, okay. Betul. Okay, tak bagi kita. Okay, bagi ni bagi orang. Okay, Ishan, the A1, what did you get? The term A1?
Doctor, for term A1, it is minus 0.021.
For the whole determinant or for just A1?
Only for A1, doctor. But if I did the full one, then the answer is minus 0.0022.
Okay, your determinants for the whole set is correct.
Yes,
but
yes.
for A1, you get 0.02.
I actually multiplied with 0.3, doctor. I shouldn't multiply. If I don't multiply with 0.3, then it is for A1, it is doctor minus 0.07.
Okay, I understand. Okay, yeah, it's correct. Just this one, right? Just the bracket is 0.07, and if you times multiply with 0.3, then you get minus 0.21. Okay.
Yes, doctor.
Okay, so okay, everybody clear? So we solve these determinants, and the answer we get minus 0.0022. Minus 0.0022 or 10 power minus 3, okay? So, okay, we're not finished yet. That is just the determinant. So, by using Cramer's rule to find the x1, x2, x3, okay? I need to erase this, because we don't have enough. Okay, even this one, okay? So, so x1, okay, if you want to, by using Cramer's rule, if you want to find the x1, okay, so again, we have to calculate the determinants, okay, like this. So the below will be the D, the determinants that, of the whole matrix A that we calculated 0, 2, 2. Okay, just now. Okay, but here we still need to calculate this determinants. So the step is a bit long. Okay. So what do we do? Okay, for x1. Okay, x1. Okay, we look at this. So we close. Okay, this column. x1, so we just look at this x2, x3. So we write x5 2 1 0.3 and 1 1.9 0.5. Okay, so for the x1's row, we will replace it with B, this matrix B. So minus 0.01 0.67 minus 0.44. So only the x1 row, we replace it with matrix B. Negative 0.01, 0.67, negative 0.44 for x1 throughout the row. Okay? x2, x3, we copy the same. Okay? For matrix A. So and then, so it's a bit long. Okay, so we to get the value of x1, we calculate these determinants. Okay, so like the usual, the same calculation, the same steps as before to calculate D, and then divide by the determinants that we have calculated previously, minus 0.0022. So we get x1 like that. Okay. So that's how we solve linear algebraic equations by using determinants and Cramer's rule. So the same for x2. you just replace it. So x2, copy back the s1. So s1 will be inside, okay? Okay, close x2, and then s3 the same thing. So the x2 row will be replaced by the matrix B again, negative 0.01. So it will be in the middle here, okay? In the x2 row. Okay, understand? And then divide by again negative 0.0022. So you calculate determinants and you get the x2. And the same for x3. The determinants, replace the s3 row with B, matrix B, and calculate, divide by minus 0.0022. Okay, so that is the steps for Cramer's rule. So I just give the answer. Okay, we are not going to wait, but you can practice by yourself later on. So we have this one minus 14.9 or minus 15. Okay, nearly minus 15. And then x2 minus 29.5, nearly 30, minus 30, and x3 19.8, nearly 20. Okay, so for example, like I've said last week, in numerical analysis method, we are not going to find the same exact answer with by using different methods. Okay, so maybe if you use other methods that I'm going to show you later on, Gauss elimination method, Jacobi's methods, you're going to find maybe S1 15 minus 15 minus 15.2, S2 minus 30, S3 20. So that is still correct. It's just that how far you are from the supposed exact answer. Okay, maybe you find something along the line, something along the around the correct answer or the expected exact answer, exact solution. Okay, so that's how that's what numerical analysis method is are used for. So we have different kinds, several methods to solve the same problem. So depends what are we going to what we need to optimize. Sometimes we need extra time or we have only limited time to solve. So we try to find the method that is the easiest, or maybe not the close possible to the exact solution, but it is the easiest or the fastest method. So we use that approach, that method A, for example, right? So it depends what do you want to optimize in terms of your solution. Whether you want to have the correct solution possible despite longer times to compute, or you want to find the whatever answers approach, okay, as possible, as long as it is the easiest or the fastest. So it depends. Okay. Okay. So back to my slides. Okay. Actually, maybe for to solve linear algebraic equation, there's a lot more other. But here in our class course, I think I will show only 3, 4 this week and next week. And next 2 weeks, method that maybe we can use. Okay, but there's a lot more in the reference book. Okay, so here, so this one actually, like I said just now, you have learned this in Maths 1, in general Maths 1. Okay, so iterative method. So other methods, for example, we call it iterative iteration by iterations. Iterative methods compare to the direct method. Direct method, which is like this, graphic or Cramer's, like this. Okay. Iterative methods are more appropriate when the number of equations involved is large. So for example, here we only have 2 or 3 linear equations. So it is possible to solve by hand manually using Cramer's rule, graphic, etc. Right? But if you have until xn, even 20, you have 20x or hundreds, 50x. So it's not possible to use these direct methods. So so we have, for example, iterative methods. Okay, when the number of questions is large. Okay, 100 or more. Okay, and obviously we are going to use computer programming. We are not going to calculate manually. Okay, they are more economical and memory requirements. Okay, okay. So for example, iterative methods. Okay, this one just now the graphic and the chemistry is, we call it as direct method, and second part, iterative methods, we have several names. Okay, Gauss, Jacobi, etc. Okay, I'll show you later on. So this iterative methods means that, okay, an alternative approach for solving sets of linear equations. Okay, so if we have the A11, S1, that like matrix AX equals to B just now, okay, so we try to, for example, the first linear equation, we try to rewrite these linear equations. S1 equals to what, S2 equals to what, okay, and convert the third line, S3 equals to P3, etc. Okay, so what do we do by using iterative methods? How do we do that? We start with initial guess for x1, s2, s3. So we make assumptions. So that's how we do when we do research. For example, in 2 years, inshallah, in your FYP, if your FYP needs to use computer programming, MATLAB, you need to program, right? So normally for your research or for your final year project, you don't have any correct, it's not like a tutorial exercise that we have, okay, if you do this, solve this exercise and then you get what the answers. But for your project, normally you have a problem to solve, a case study or problem to solve. So this normally you will be faced with a problem that you don't have enough parameters, you don't have enough initial parameters, initial values to solve that problem, right? So you need some initial values, some initial parameters. You need to guess, you need to assume, you need to make hypothesis, right? So this when numerical methods, your numerical methods knowledge come into the scene in your FYP later on. Okay, so you need to, okay, you don't have enough initial values, okay, to solve the problem. So some of the parameter you need to guess, you need to make assumption. But of course, your assumption cannot be just any numbers or any values. It has to be, if you do FYP or research R&D in your future, you need to, of course, defend your assumption. Right. So, for example, okay, okay. Example, if x1, example, if x is temperature, a set of value of temperature, you have T1, T2, T3 that you need to solve. Okay, for example, right? So, and you have a problem or case study where the problem setting, you are in a room temperature. You are in a room or in a lab, and you have a hot water, etc. So you need to solve to find the temperature of a different fluid, for example, in a room. Okay, so you need to guess first T1, T2, T3, right? Temperature. So of course, the value that you guess, in order to start the iteration methods, you can't just, for example, you can't just guess, T1 200 degrees Celsius, T1 T2 500 degrees. Your assumption, yes, we can guess, but your assumption is is not approaching the real situation, right? If we are set in the same, if we are to solve the problem, of course, for me, I will put, or maybe T1 around room temperature. I will set assumption T1 30 degrees, 27 degrees Celsius, right? Okay, so we make assumption, but our assumption has to be logic. We cannot just put anything. That is where physics come into the scene as well. So you need to defend why you choose your assumption, initial guess, temperature 30 degree, 27, because it is near, we assume at start, at the beginning, the temperature of the fluids are near room temperature. So we guess, we make assumption T1 27, 38, 39 degrees, something like that. Okay? Okay, so that's how we relate this numerical analysis method with problem solving in a case study or any mechanical or physics problem. Okay. So we need to start with initial guess for S1, S2, S3. Okay. And then iteratively substitute all values of S1, S2, S3 in the right hand side of the equations to get updated values of S1. Okay, so basically what in the iterative methods, what we're going to do, how do we solve this, is that okay, first, for example, if I choose S1, S2, S3 as 0, for example, the initial value 0, S1, S2, S3 0, and then so for X1 here, okay, so when I want to calculate the X1, when I want to calculate the S1, so S2 0, S3 0, so I will only have B1 over A11. So that is my X1. Okay, and then I will repeat. Okay, and then this X2, S1, S3, A22. Okay. Okay, so that's how it means it here. Iterative substitute all values of S1, S2, S3 in the right hand side of the equations to get updated values. So we update until when? Okay, we will see that until when. Okay. Okay, so for example, we have two. Actually, I'm going to show you only two iterative methods. Okay, so the first one is called Gauss-Seidel methods. Okay. Okay, this the first one. We call it as Gauss-Seidel method. Semua okay Everyone okay? Dekat seorang-seorang
Okay, doctor.
Okay, doctor.
Ya, doktor.
Okay. Okay, Gauss-Seidel method. Update the values of X one by one using the latest available set of X. Okay, faham tak? You understand? Start with initial guess X1, 0. Okay. Okay, so we X1, 0 here, when we write X1, 0 here, or S1, okay? This means, doesn't mean S1, S2, S3 is equal to 0. This notation means that S1, S2, S3 at the initial state, at the beginning. Okay? 0 here, not 0 in terms of value, but 0 means 0 at the start. Okay? So if we have I, okay, so I equals to 0 at first. Okay, I 0, we have S1, S2, S3, S1 0, S2, S0, okay? And then, okay. And then we compute X1, okay? So this time we have I plus 1, okay? The next step, the next loop. If you know the loop, right? One loop, second loop. So we have I. So X2, I plus 1 also. X3, I plus 1. Or sometimes we write like this in terms of matrix: S1, S2, S3, and we put 0 here. X1, X2, S3, I plus 1. Okay. Okay. So, okay, if we use the Gauss-Seidel methods, means that, okay, okay, like example just now, okay, for the initial value of S1, S2, S3, I put 0, we put 0, 0, 0, 0, or 1, 1, 1, okay? So, so the first loop, okay, the first step, okay, X, to find S1, I put 1, S1, 1, okay, because X1, 0, okay, 0 lah, okay, 0, 0, 0. Okay, so we have 0, 0, 0 matrix. Okay, at initial. Okay, so to calculate the x1, 1, the first round. So B1, sorry, like I said just now, so x2, B1 minus A1, 2. Okay, so this is x2, 0. Okay, so don't get confused. Don't be confused. Okay, so here is the it's already in the, we are already in the second round, second loop, x11. We are going to find x11, but here is x. We use the x2 0 because we don't know yet x2, right? So we use the first assumption of x2. So here it should be 0 lah. If you guess it as 0, so here should be 0, and then minus A13 x 3 0 atas ni kan. Okay, 0 above A11. Okay. Okay, so this term will be 0 if according to what we have guessed assumption assumed here. So we only have B1 minus A11. So that is our x1 x1 at step 1. Okay, so x2 step 1. Okay, the question for x2 step 1, by using the Gauss-Seidel method, you write B2 minus A21. Okay, so x1 is the x11 that we have achieved, that we have found just now, previously. So this is x11. It is no longer 0. Okay, it is no longer 0. So S1 is the value of B1 over A11. Okay, so and then A23, X3 0, still S3 0. Okay, because we don't know yet the value of S3. So this will be 0. Okay, A22. So that's how you get the X21. And then last one, X31. Okay, so B3, A31, X1, S11 again, okay, that we have found here, minus A33, okay, minus A33, X2, 1, the one that we have just calculated. Okay, so A33. Okay, so that's how we find X31. So and then we repeat. Okay, and then we repeat the loop, the step. Okay, so this one will be x12, B1 minus A12, x2, 1, minus A13, x3, 1 that we have found previously. Okay, so repeat that again. Okay, that is how we solve a linear equation S1, S2, S3, and etc. and the Sn by using Gauss-Seidel method. Okay. Another one is almost the same but just a bit different. Okay. Jacobi iteration. Okay, the Jacobi we still need to make guess. Okay, but the different part from Gauss-Seidel just now. Okay, so again, we start with initial guess S1 0, S2 0, S3 0. So again, if you assume 0, 0, 0, and then but the difference is here. Okay, when we want to calculate the x11, this is B1 minus A12, but here, okay, x2 0, okay, for x1 is still the same. Okay, for x2, for x21, B2 minus A21. Here is not S11 like Gauss-Seidel just now, but the value that we put is S10, which is 0 here. Kat sini this term. The first one S1 is the same as Gauss-Seidel, but for X2, according to Jacobi's, by using Jacobi iteration, when you want to find X2 and S3, we still use the initial assumption here, S1 0, S2 0. Okay, here for S1, S3. Okay, 0, 0. This one also 0, 0. Okay, that is the difference, Jacobi and Gauss-Seidel. We still use the initial value. Okay, tengok balik. Look back. Okay, the different part. Okay, for Gauss Seidel, once we get the S1, we already replace it here, even in the first round to get the S2 and S3. But for Jacobi, we still use the initial value until we finish the first round. For all i's, for example, I equals to 1. For all I equals to 1, the first round, we still use all the initial value until Sn. And then second round, second loop, I equals to 2. And then that's when we use the all sets of x that we found previously when I equals to 1. So the different part for Jacobi's, you have to imagine this when you want to program this in MATLAB or Python, etc. Jacobi means that okay, when I 0, okay, so we have S1, S2, 0, S1, S2, S3, so error is small. Okay, and then when we want to get I 1, we still use all the initial value 0 to get x1, s2, x3 at 1 at first round. Therefore, I2, then we use s1, s2, s3, this one, okay? S1, S2, S3, 2. Okay, so etc. until n iteration depends. Okay, so this one we set how much iteration that we have to find. More higher value number of iteration I is better, but again depends on your it will take longer, okay, time to solve. Sometimes the software will crash or jam, etc. So need to use appropriate suitable number of I. For example, me usually I will start with I equals to 10, means we do 10 rounds, and then we increase a bit by bit, okay, not too big, okay. Don't start I equals to 100 directly, okay. Otherwise, the computer programming sometimes will jam, okay, or take too much time. So you will see, okay. So that is the difference between Gauss Seidel and Jacobi iteration. Both are iterative methods, but the steps is a bit different. Okay, so this if we want to draw it a bit, the difference between Jacobi and Gauss Seidel. So which one is that? So obviously this one, the left hand, the left hand side is Gauss Seidel, and this one is Jacobi, right? Okay, the difference is here. Once you get S1, you for Gauss Seidel, when you get S1, you will replace it in here, and you calculate S2, etc. And when you get S3, you replace it here, and you use the S2 just now. Okay, like this. Okay. But for Jacobi, we finish first the first iteration without changing the S1, S2, S3 in the equation until we finish the first iteration. Then second iteration, then we will use the set of first iteration that we have had here. Okay. Okay, just so Gauss Seidel, Jacobi. Okay, so like I said just now, so when do we start? When do we stop? Okay, right. So we do a computer programming to solve a linear set of equation solution to find the solution. So what is our criteria of stop? Okay, to terminate. Okay. So normally we will set a stopping criteria which are in terms of percentage relative error. Okay, so once we find that for example here we call it the error, the percentage error, we call it we write it in terms of epsilon. Okay, epsilon. So the epsilon, usually we will put it to be more precise as possible. We will we will choose epsilon as less than 10% or even better, less than 5%. If you do your FYP in the next 2 years, inshallah. So if you have to do programming, so please set your error relative or epsilon. You have, when you want to validate your model, your data, you need to find you need to have the error less than 10%, I think. Less than 10% will be better. Not to 20 to 10% is not really acceptable, but yeah, depends. But if you do master or PhD, it's more, we need more accurate results. So at least you have to have 5%, less than 5% error. Okay, this error means that x1 like this. We okay. For example, we have this x1, I is 1, means that we want to find the x1 first. So j is the iterative value. I mean iterative round. J 1 and then second loop until n loops. Okay. So we how do we calculate the error or the epsilon? For example, like just now this one means that the second the second iteration, yeah, this first iteration, second iteration, right? Okay, so like this, epsilon should be a positive value. X1 first. So for example, you have the second iteration minus x1 from the first iteration over x1 the second iteration, okay, and times 100%, get the percentage. So until we get the difference between the second iteration and the previous iteration, less than 10%, right? For example, the error, if you put epsilon less than 10%, then once we get the error less than 10%, then we stop the iteration. Then the iteration will stop. Okay. So it's up to us to choose the value of epsilon area here. But this the smaller the value of epsilon is, the better the results that you achieve or get. Okay, so means that we have the value of this and value of this is very close. For example, if you have 4 point until we get 4.998, this one 4.98, like that. Okay, so and then we said yes. Okay, we have found the solution. The solution is x12 4.998. This is the solution. Okay, because the error of the current iteration and the previous iteration is less than 10% or 1%, 5%. Okay, so like that. Okay, so we stop. So the programming will stop. Okay.
Doctor.
Yes.
We are doing all the calculations in the program. So why don't we go for even a better result, like less than 2% or so on?
Yes, of course. But of course, we want to get the closest solution as possible. But depends. Sometimes even you try to achieve, to get the smallest error as possible, you couldn't get. Sometimes okay, you try, okay. You will face this when you do FYP or your project, etc. in future, your research, for example. we try to get the smallest percentage possible, but we cannot achieve that sometimes. Okay, because it depends back on the assumption, the assumption that we made in the initial value, initial guess, right? Okay, so sometimes even if we try to get, okay, the smallest error, we still couldn't achieve. So that's why sometimes we have to settle, even though you only get the error until 10%. We have to stop, right? Because we cannot proceed further. Okay, there must be maybe our initial assumption is wrong, or is really far from the real situation. Sometimes we will face in that situation. You understand, Ifan?
Yes, doctor. Thank you,
Of course, you
doctor.
want to get the right possible answer in your test, in final exam, of course, in your assignment. But yeah, when you do project or research, we cannot. Sometimes we cannot achieve. Otherwise, you do your PhD 10 years, 20 years, you won't finish. Okay.
Okay, doctor. Thank you, doctor.
Okay. Okay. This is an example. Okay. 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 This one is the previous. I think the same. No, okay, no, the same. Okay. So for example, this you have this matrix. So actually, the answer already put here. Okay, but we can we can try. You can try by using to solve this set of equation by using the Gauss-Seidel method. Okay, to solve this matrix linear three linear equation S1 S2 S3. So the answer is already given here, 3 minus 2.5, 7. Okay. 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 So okay. So this one ini sama je. Okay, this is the same. Okay. Okay. So try to do this later on. Okay, I will upload the slide. And then what else? Yeah. Okay. So this is example. Okay. Okay, I try to explain this first. Okay, the example of how do we program this in computer programming, MATLAB or Python, etc. Okay, so for Gauss-Seidel iteration. Okay, so for example, okay, so we have this set of question, right? Like just now. Okay, this three to solve the S1, S2, S3, right? Okay. So this is just an example, okay? Doesn't mean this is the only methods, okay? Steps to use the Gauss-Seidel, okay? To program the Gauss-Seidel. So for example, you have I from 1 to n, okay? And then we call it the dummy or anything you want to call it. The matrix A11, A22, A23 means, for example, the first round. I equals to 1. So the dummy is A11. And then we have the loop. You have learned about the loop 4, right? 4 in your subject computer programming, ECC 3005.
Yes, doctor, we have.
Okay. So we use this loop. Okay, for I 1 to n. So dummy A11. And then for j equals to 1 to n. So we have A11 again, equals to A11 over dummy. Okay, I'll write this. So when you do computer programming, try to write it first in a paper, anything, and try when you do the loop for, try to imagine how the computer solve this loop. Okay, you have to try to write. Okay, that's how I do lah. Okay, so for example here, if we do this programming, so we have dummy. So the first round will be dummy A11. Okay, so and then J. You know how to read programming language, right? Okay, so if you have two loop 4 at the same time, means that for for I equals to 1, and then we need to solve for j equals to 1 to n. Means I1 and j 1 until n. And then we go to I2 and j 1 until n. Okay, until we get we repeat again I3 j 1 until n. Okay, that's how the computer will read your programming. Okay, until I equals to n, and then j 1 until n. Okay, apa tadi? So A, okay, the first round, I1, j also 1. So A 1, 1 minus the dummy. Dummy here is A11. So actually you have 1. Sorry. So actually you have A11. So you get this for the first round you get 1, and then B1 for the matrix B you have B1 over A, the dummy first round A11. Okay, so the first steps of this programming, we try to write this linear equation, means that okay, B1 over A11 here, right? The first term. So this is B1 over dummy A11. Okay. And then, okay, A11 over, this is 1. Okay, so and then if we, next one, j equals to 2. The dummy A11 is still the same because we have to finish this loop first, j until n, and then we'll get back to the above. Okay, so for example, j2, A1, 2. So A1, 2, A1, 1. Okay, the dummy hasn't changed, and B still B1. Okay, B11 over A11. Okay. Okay, so the second step we are writing. We try to write this A12 equals to A12 over A11. This one, okay? So and then etc. until j equals to n. Okay, but we haven't finished yet. Okay, and then continue. Okay. Okay. So for I1 to n, the sum is the matrix B1, Bi. So if I is not equals to j, means that if for the first round I1 j1, so if we encounter this one I and j is equal, then we won't proceed this step. Okay, directly we exit the loop and continue with j2. So j1 we won't proceed. Okay, because this stated here, if I is different than j. If only I is different than j, then we do the sum. If I is equals to j, then we exit the loop. Okay, and look for another j. Okay, so when j equals to 2, I1, j2, then we can proceed this if, this statement. So sum if B1, the first one, so equals to B1 minus A12 minus x2, right? This B1 minus A12 x2, B1 minus A12 x2, okay? And then we repeat J3, okay? So if J3, then J is different than I, then we can proceed this statement, this process. So again, sum is equal to this sum. When you go to when you entering the second or the third round, the next round, this sum is the previous sum. It's no longer the initial sum that we have. Okay, that's why we need to understand how the computer program read your equation. Okay. So when you write, sometimes when you write the program equation, try to write down when you enter your program language, computer program. Try to write in paper try to imagine how computer read your equation, so that you make sure what you write is what you want the computer to understand, to read is the same what you imagine. It's what you imagine. Okay. I write the sum. Right. Okay. Yes, sorry. Okay. So B1 is now B1. Okay. So equals to B1 minus A12, right? A12 x2. Okay. Okay, so we have this, and then we proceed J2, J3 kan. This is J2 because J1 is not we are not we won't proceed this step for J1, right? So this is J2, J3, B still B1. So the sum here, the computer will read the sum of this previous sum in J2 that you get, not the first, not only this B1, okay, not this B1 sum. Okay, for J equals to 3, what the computer will read is not your initial sum, but the previous sum that it records in his or her mind, the computer's mind. Okay, so you have to imagine that. Okay, so computer dia faham apa yang awak record sebelum just previously, bukan yang awak record yang dulu-dulu tu, dia dah tak ingat lah. Dia ingat yang ni. So dia akan ambil yang sebelum tu. Okay, so that's how you read the computer language. So the sum here is actually the whole this. Okay, so B1, A12, X2, then minus, then minus all of this. Then minus A13, J3, X3. Okay, so you get the program like this. Okay, B1, A12, S2, A13, S3. Okay. Okay. Right, mana? Okay. Oh, okay. So actually B1 here, because here you already divide the B1 over dummy, which is A11, right? So actually this one is already divided by A11. A11. So this, when you get the sum, so actually you already get the x1. So because you already divide it by A11. Also the A1J pun you dah divide dah. Okay? Okay? A11. Because you divide first in this first loop. So the second loop, when you put this Aij is actually Aij of A12 over A11. You already divide by A11. So that's how you get directly. You can call directly S1, X1 equals to the whole sum. Because already divide here. Okay, so that is example. So you continue this until Jn, and then when you finish Jn, then you go back to I2. You only finish for I1, and then you go back to I2, etc. Okay. So that's an example how you program the Gauss-Seidel. This is again I mentioned, this is not the only approach, the only solution, the only steps how to write the Gauss-Seidel in your program. So the code Gauss-Seidel iteration. Okay, maybe there are other possible steps, method, okay, to key in, to code your Gauss-Seidel iteration. So this is just an example, okay, not the only solution. As long as you get the approach solution, okay. This is just this example. Further, if we want to make sure our solution, the x1 as x that we have, the solution that we have less error, then we put a value that we call lambda. Lambda is like a bit like the epsilon, means that you attenuate, okay, your calculation, your error, so that you won't get error too big. Okay, so just example. So you put lambda here, okay, in the equation x to attenuate your solution, the possible error in your solution. Tak apa, ya. Okay, so that's all actually for this part today. Jacobi and Gauss-Seidel iteration methods. So the iterative methods may not converge. Also sometimes, like I said, sometimes if you put too big the number of iterations, then or the error is too small, the percentage error is too, you try to achieve the smallest possible error, and then you cannot find converge solution of x, then your program will not stop, will continue, or will find error. Okay, so it means that you have to change your assumption, your percentage of error, or maybe your initial guess. Okay, so we have to play around with that. That's what numerical method. We have to play around with the values, numbers, etc. Okay, so we have to set the stopping criteria or converging criteria. Okay, that's all. Okay, so okay, yeah.
Doctor, for this code will be the same forever, right, Doctor? We don't have to make any changes in the code, right, Doctor?
Changes in the code.
This code is already perfect, right, Doctor? We don't have to make any changes in the code to get more accurate answer, right, Doctor?
You can use
Doctor,
the
what
code.
I'm trying to ask is, we don't have to make any changes in the code, even for our masters and PhD, right, Doctor? We can use the same code.
We can use it, but okay, just now I think we didn't have the, okay, this code didn't set the converge criteria or the stopping criteria, right? So I think if you have a larger set of equation, you need to set the stopping criteria or the error, the epsilon. So so you have to ask the computer to stop. Okay. So you can use this, but if your question for future for higher degree, if we can use this exact, maybe yes we can use, but I think you have to add extra assumption, extra, depends on your problem. Okay, this is the I mean that you can use this as basic to start your iterative methods calculation, but I think you need to add extra criteria in order to solve your case study problem. Okay.
Okay, Doctor. Thank you, Doctor.
Okay, so I just go back to this one. Okay, so using Gauss-Seidel method, okay. Do we have time? At least I'll show is the first first few steps. Okay. So we have this matrix. So try to write down this matrix first. Gauss-Seidel. Okay, this is Gauss-Seidel. Okay. Use Gauss-Seidel method. Okay. Oops. So we have 3 minus 0.1 minus 0.2, 0.1, 0.3, 7, minus 0.2, minus 0.3, 10, okay, and then matrix S1, S2, S3, okay. Okay, so first one, okay. So if we use a Gauss-Seidel method, then we write x1. Okay, we change equation like example ni. Oh, this one we have to use B1, B2, B3, Gauss-Seidel, X1. Okay, so B1, 7.85. Write this in linear form. So you have 3x1 minus 0.2 x2 minus 0.2 s3 equals to 7.85. So if we rewrite the equation, so you have 7.8, like below one, 7.85 x2 plus x3 divide by 3, okay, and then etc. s2, s3. So we assume initially x2 here, okay, use Gauss-Seidel method. So this one is 0, this one is 0 also. So you get x1, the first step, okay, you get x1, 7.85 divide by 3. 7.85 divide by 3. Okay, so you get around 2.6 1 take enough, 2.616, and then for Gauss-Seidel method, so when you want to calculate x2, you already replace this s1 with 2.616, not 0. If you use 0, that means that is Jacobi method. Okay, so this one is 2.616 that you get, and then s3, this one 0, so you get x2 minus 2.79 4, okay, 3 dah cukup kot, 3 or 4 digit after the point, okay, decimal value, and then s3 you get 7.0056, like that. Okay, so and then repeat the second round, second iteration by using all the set of values that you found in the first iteration. So okay, so if you do it manually, then we need to at least set. Okay, for example, in your test of financial, I need to set the criteria for you to stop. You cannot do until 10 rounds. Okay, so at least this one, at least do first iteration and second iteration. That's enough. Okay. So we get epsilon error maybe 0.30%, etc. Okay. And only after 2 iteration, then we assume that is already correct solution. Okay, so try to calculate, okay, by your own self later on. Just 2 rounds, 2 set of iteration, and then you try to get 3, maybe not exactly 3, but near approach to 3, minus 2.5 and 7. Like here, the first iteration we get S1 2.6, right? Okay, nearly 3 already. And then this one minus 2.79, okay, the solution is minus 2.5, and this one we get 7.0056. So nearly 7 already. Okay, so you just do 2 rounds of iteration. Okay, because we do manually. If we have computer programming, then we can increase the number of iteration. Okay.
Doctor,
Yes.
just to make sure, to find the x2, we input the 2.616 for x1 and x3, right, doctor?
Not okay. The first round, right? The first
Yes,
iteration
yes.
round. Okay.
Yes, doctor.
So x1 is 2.616,
Yes,
but
doctor.
x3 is 0. You don't know
okay,
yet.
okay.
You don't know yet. S3, right? You don't know yet. So you use the initial guess, which is we assume here 0.
Then, doctor, for x3, we can use both the values of x1 and
Yes.
x2. Okay, okay. Thank you,
This
doctor.
one. This one. This one, right? So you include this 2.6 here, and then you get negative 2.79. And then here you use 2.6 and negative 2.79.
Okay, okay, doctor. Thank you, doctor.
Okay. Okay, that's all for today. But I'm going to silap. Okay. Wait. So as I promised, okay. I'm going to give you assignments. Okay. So I need to show the assignment slides. So next week we don't have online live course. Okay, so it means that I'll give you times. Replace the lecture times with assignments. Okay. Wait, Okay. Loading. In the meantime, you try to calculate this.
Doctor,
Hmm?
can I ask one more thing, doctor, please?
Mm-hmm. Yes.
Doctor, for the second round, we'll start by using the x1 from the first round. But then we have x1 value for second round too. Right, doctor? So for x2 and x3 in the second round, should we use the x1 value of first round or the second round?
Okay. So okay, second round. So you want to find x1 2, we put here 2. Okay, second round. So x2 here is the x2 minus 2.79.
Yes,
S2
doctor.
1. S3 1. And S3 7. 7.00 here.
Yes, doctor. Then we have another value, the x1 value for the second round. Right, doctor?
Yes, this one, huh?
So for to find the x2 and x3 in the second round, we
Yes.
will use this x1 value of second round, doctor, or first round?
Yes, the S1 value
Second
of
round.
this second round. Okay,
Second
you
round.
just you just look back at this slide, okay? You use
Okay,
the
doctor.
same rate. Okay?
Okay, doctor.
Okay. Share this. Okay. So, okay, I will upload this assignment later on in Putra Blast. So, this is your first assignment. Okay. Okay, the instruction is okay. Okay, this is the question first. Okay, later on I'll show you the instruction. Okay. So you can read it. So we have a problem. Okay, I think you're already familiar with this problem. Even in Maths 1, I think for the students, I give you this kind of the same problem. So it's normal mechanical problems, statics, okay, if you have a spring mass system, a spring mass systems, okay, etc. So with a constant K, right? When we apply force, okay, at each of the mass, so what is how do we write the force balance in terms of mathematical model, which is Newton's law, by using Newton's law? We write the equation, okay, the balance force equation, okay, Hooke's law, okay. For these three mass, M1, M2, M3, so we solve this, okay, at this point numerical methods can be employed to obtain a solution. If M1, okay, we have M1 2 kilogram, M2 M3 2.5 kilogram with acceleration 9.81, and we assumes the case, the constant value 10 kilogram per second square. Okay, so we can solve this problem, mechanical problem, the spring mass problem, by using linear algebraic equation. So I give you freedom to choose whether you want to use Gauss-Seidel or Jacobi methods, okay, to program this equation, this type of algebraic equation, to solve to get the solution, okay, S1, S2, S3. So means that you have to write the mathematical linear equation first, and then program it, and then you solve the equation. It just means that just three linear equation, right? You have three mass, and S1, S2, S3. Okay, so recall back the Hooke's law, the equation of Hooke's law, you know, okay? So use the value that we have here. Okay, so and then so the instruction. Okay, since I changed a bit what I told you last week. Since you guys 60 of you, even now I think just now I saw 60 to 61, 60. Okay, minus me, so 60 of you. So I need you to be in a larger group, not too large, but larger group. So at least three or four, please, because otherwise I have a lot of assignments to mark. Okay, so we have 4 assignments for numerical method and then other subjects as well. So at least I will have too much, okay, assignments to review. Okay, so the assignment is to be done in 3 or 4 persons in this group, if possible please 4. Okay, 4 persons in each group. Okay, so each this assignment will account for 10 marks, so you have 4 assignments, so 10 until 40%. Okay, the program must be general, can be used to solve any similar linear algebraic equations. Okay, what I mean by this is that actually I don't want you to just key in the value, right? You in your okay, first you can use MATLAB if you have. If not, I think you guys are more familiar with Python, right? Because you have learned Python with Dr. Yazdi, I think. Right, last year.
Yes, Dr. Python, but with Dr. Sharil for our
Dr.
time.
Sharil.
Okay. So you can use whatever computer programming software that you have, or maybe even C-Lab. I think C-Lab also possible. Okay, the free one that you have. Okay, so you can choose in whatever, okay, that you are familiar with. Okay, so what do I mean by the program must be generous? Because I don't want you to just key in the value. For example, just now you have M1 2.5, for example, and then you just calculate like you calculate in calculator. So I don't want that. Okay, so it means that you have to put a general parameter, like just now a dummy, or B, C, and then means that if we enter any value of matrix A, not just for this problem, means if we enter any value of A, we can use your program to solve any set of linear equation. Okay, so I don't want you just to key in the value like you just calculate it. Okay, want to be it can be generous. So if we change the set of linear equations, the program is still can be used. Okay, so that's what I mean. Okay, so submit your programming code with the answers. Okay, so you not long report, just a cover. Okay, cover your name, your group team names, and then just one page of the programming code. Okay, save your programming code, and then at least I can see the answer. Okay, if you want to sketch the graph, maybe not this assignment, but next assignment, if you have a graph to sketch figures, then you can include also the figures inside the report. Okay, just simple lah. No, you don't need to write anything thesis or what. Okay. Okay, and then record less than 10-second video of programming. Okay, just record around 10 seconds, not exact 10 seconds, plus minus video. I just want to see how the program that you code can be used. Okay, just to see the means that you run the simulation, the program, and then you record it, and then until it appears the program show you the answer of X or the solution. Okay, I just want to see that. Okay, so means that you have to submit just the coding and the figures if you want, and then the video just around 10 seconds, 20 seconds video of your programming running. Okay, and then email your answers, okay, your assignment to me. Okay, that's my email. And so, okay, like I have mentioned, I will give you deadline 2 weeks. Okay, because another 2 weeks I'll give the second assignment. 2 weeks. So I don't want you to simpan concept. Okay, assignment and do the assignment until end of the semester and submit all 4 assignment at the end of the semester. I don't want that. Okay, is for your benefit as well, so that you won't have lots of assignment at the end of the semester. So I want you finish one assignment, you submit. Finish one assignment, you submit, and then you won't have lots of assignment at the end of the semester. And for me as well, so that I can mark assignment bit by bit, a little bit, so not lump sum at the end of the semester. Okay, so I give the due date in 2 weeks, 12 April, just before Ramadan. So if you submit late, okay, if you submit late, maybe around 24 hours, not 24 hours, 12 hours, okay, like 12:01 in the morning or 1 a.m. said, I will still accept it. But if you submit like a few days later, I will maybe I will accept, maybe, but I will cut marks. Okay, so try to submit by the deadline. Okay.
Okay, doctor.
Okay. Okay, I think that's all. Okay, that's all from me for this week. For this chapter 1. Okay. So I stop here. Okay, so do you have any questions? Okay, saya tak tengok. Kalau kira pakai Excel tak boleh lah kita belajar. Cannot lah kita belajar numerical. Kita kena guna program lah. Tak malah Excel. Boleh lah. Tapi, but of course, maybe you can solve with Excel, but here we are in programming class. We want to learn how to program, right? Okay. Maybe you can use Excel just to validate, to verify your answer. Okay. But please do programming, okay? Okay, so attendance. So there are 60 of you here. 59 right now. Okay, tak apa. Okay, mana? Attendance. Okay, this one. Hope it works. Okay. So like last week, just fill in the attendance. Okay, so now is so we finish now. Now it's 3:47. So I'll give 5 minutes And then after 5 minutes, I will close the attendance form, okay?
Doctor, will we get the slide in
Yes.
start? Okay.
Yeah. Saya akan upload semua. I will upload all the slides. Cuma bagi masa sikit. Because I want to upload with this video. Okay, stop the video. So it must takes a bit time to convert the video in YouTube, etc. Okay. Stop recording.